solve a polynomial inequality given in factored form. So in this particular question here, we are starting in a factored form. So we're going to solve the inequality 5x times 2x minus 3 times x minus 3 is greater than or equal to 0. Now there's really two different ways to do this, and I'm going to show you both of them. So first, either way, you need to find the zeros. So with inequalities, we want to make sure that we're equal to 0. And now, where would this graph cross the x-axis, right? Those are the zeros of the function. And because we are in factored form already, we have 3 pieces. If we set each of those equal to 0, those will be the zeros of our polynomial. Okay, so we know if 5x equals 0, then x is 0. If 2x minus 3 equals 0, then x is 3 halves, which, remember, is the same as 1 1/2. And if x minus 3 equals 0, then we have x equals 3. Okay, so we have 3 zeros. Now, the first way we're going to talk about this is solving by graphing. So we have a graph. Now, we knew that our 3 zeros, we have one at 0, at 3 halves, and at 3. Okay, great. Now let's revisit what our polynomial is. So we're f of x, no, I'm so sorry. We are 5x times 2x minus 3 times x minus 3 is greater than or equal to 0. Hopefully you recognize x times x times x. This is a cubic function. And what does a cubic function look like? Well, it starts low, ends high. So think about end behavior. If you know that, you can say, well, just a quick sketch, start low, end high. This is what our graph looks like in general. We don't know, it's not perfect, but in terms of what a cubic function looks like. If I graph that, and now I'm saying, where is this greater than or equal to 0? Well, that's where it's above the axis. So we could say, well, from 0 to 3 halves, and then from 3 to infinity. Notice that I'm using brackets because we are equal to. Okay, that's one way to do it. The other way, if you don't like the graphing part, you can say, okay, I know my zeros are 0, 3 halves, and 3. So if I have myself a number line, I'm looking at each of these intervals to see what's true. Now, once again, we've got 5x, 2x minus 3, and x minus 3. And I need to check a number in each of these intervals. So if I want to go to the left of 0, let's try -1. So 5 times -1 times 2 times -1 minus 3 times -1 minus 3. So that gives me -5 times -5 times -4. Well, a negative times a negative times a negative is a negative. That's all I really need to know. Okay, now on the next spot here, let's try a +1. So 5 times 1, 2 times 1 minus 3, 1 minus 3. So that gives me 5 times -1 times -2. Well, 2 negatives is a positive. Okay, now between 1 1/2 and 3, let's try 2. So in this area, so 5 times 2, and then 2 times 2 minus 3, and 2 minus 3. So 10 times 1 times -1. Well, 2 positives and a negative is a negative. And then to the right of 3, we can try 4. So 5 times 4, 2 times 4 minus 3, and 4 minus 3. So that gives me 20 times 5 times 1. 3 positives is a positive. Now remember, we were looking for greater than or equal to 0. That means we are looking for positive numbers. Well, it's positive between 0 and 3 halves, and it's positive from 3 to infinity. So whether you do the intervals, check a point, or sketch the graph, look where it's above or below the x-axis, either way you get the same answer. Just remember, if you're going to use the graphing piece, well, either way, you have to get it to equal 0 first so that you can compare it to this spot where, the x-axis where y equals 0.